So good afternoon, my dear student. Last class I discussed about the very basic of single phase DC drives. Okay, single phase DC drives. Then especially for single phase. Then after that I discussed about the single phase dual converter. Basically, the purpose of the dual converter. You know that we can use both of the cases. Okay, both of the cases means motoring mode as well as the braking mode. And the rating is you can check it around. Up to 15 kilowatt. Okay, so 15 kilowatt means it is more or less medium size of motor. Okay, so not so very big size of motor, but still we are using it. So as we are using different power electronics converters, so definitely some of the advantages are there. So then we can understand the single phase operations. Okay, in single phase we are getting the DC from the single phase source. Okay, but if we have the three phase drive, so what will be the advantage? Normally what happen in say single phase, you can see it, so you will get how much value for after conversions. Okay, that is important thing. Okay, so you will get that frequency like that 100 hertz. Okay, so you have that 50 hertz alternating signal, so if you rectify them, so you will get it 100 hertz. Okay, means pulsating DC. In that case what you need to do, so pulsating DC is there, so we can pulsating DC is there, so we can change it. We can, how do you change it? So if we have some three phase AC, so if we have that three phase AC, so we can get it, so from the three phase AC, so we can convert or rectify it to the three phase AC to DC. Then what will be the benefit? So you know that the ripple frequency will be more. Ripple frequency means, what do you mean by the ripple frequency? In that case, that how much ripple frequency is there? It is 100 hertz. Okay, now it is 3, means it will be reduced up to 1/3. Okay, so that kinds of advantage you will get, as well as the output voltage will be high. Output voltage means average output voltage will be more in this case. Okay, average output voltage, what do you mean by the average output voltage? So normally you will get that output voltage 2 Vm by pi. Okay, cos alpha, like that in case of full wave full bridge control converter. So in that case you can get 3 Vm by pi. So more or less you can understand that average value, it was started with 2 Vm by 2 pi or 2 Vm by pi, so it is coming 3 Vm by pi. Okay, so that means your average value of voltage magnitude is more or less high, so that more utilization of your input side voltage. Okay, so you will get the more DC voltage. Okay, so the range of motor operations will be more, so you can vary that throughout the range, so very less value to up to maximum value. That kinds of advantages you can observe from the study. Okay, so that's why we can switch to single phase drive to three phase drives. Okay, so what are the most important points for the three phase drives? So you can see the armature circuit is connected to the output of the three phase control rectifier. So you can understand, so three phase control rectifier. So what do you mean by the control rectifier? So control rectifier means you can change the firing pulse to vary the range of output voltage. So that is your benefit that you can do. Okay, so then next thing is that three phase drives are used for the high power application. So what do you mean by the high power applications? So you know that previously it was 15 kilowatt. So 15 kilowatt, okay, it's high, but it's not so too high for sometimes driving for the some 5 HP. Okay, 5 HP or 10 HP motor. Okay, so that's why it is not possible to. So how do you make it possible? So you have to increase the level of the voltage. Okay, level of the voltage and controlling specifications, controlling zone. Okay, so then you can see up to megawatt power range level. Okay, so that you can go. Okay, the ripple frequency that I am telling you, ripple frequency inherently more in case of three phase, in case of three phase supply based drives, okay, compared to the single phase drive. So inherently that harmonics will be less. Okay, and it requires the less inductance in the armature circuit to reduce the armature ripple current. So you can automatically ripple out the armature ripple current. Still in case of motor, if you see it's a mostly inductive portion, so automatically the ripple will be mitigated. or minimized, but still some of the ripple is there, so it also been mitigated, also been minimized by using that configurations. Okay, the armature circuit is mostly continuous. The armature circuit is mostly continuous, and therefore the motor performance is better compared with the single phase drives. Okay, so that also very better, very good. Okay, so similarly the single phase drive, the three phase drive may also be subdivided. What are the like single phase? So subdivided into different parts. So more or less rest of the thing is more or less same, only that output voltage is different. So it was initially it was single phase half wave control drive. So similarly you can write that three phase half wave control drives. Okay, that single phase will be replaced by the three phase. Same thing, the single phase semi controller drive, semi converter drive. Okay, so semi converter means both of the sides, both of the leg of the bridge converter. Okay, not like in three phase there are three legs. Okay, there are three legs, so individual leg having one control device and another one uncontrolled device. Okay, means upper you can say like that for the symmetrical configuration, upper half totally control device and lower half means lower half totally uncontrolled device like diode. Okay, then three phase full converter drives. Again three phase full converter drives means that both of the upper half leg in individual stack. Okay, that four stacks or three stacks or individual stacks, it having control both of the control switches. Okay, three phase dual converter. Okay, also the good idea. So for both of the operations like motoring as well as braking. Okay, so dual converter means four quadrant operations. Okay, three phase full converter also did that motoring and braking, but you can go maximum two quadrant operations. But in case of four quadrant operation, you have to go for the dual converter. Or other cases for the two quadrant operations, that is full converter, it can work properly. Okay, so sometimes regenerate, not like regenerative way, sometimes the braking also been required. Okay, not like only regenerative braking, the plugging also, it is four quadrant means fourth quadrant operation. So in that case you have to go for the dual converter, means you can vary the firing pulse with the summations with the some other values. Okay, means equal to pi. Okay, some conditions are there. Okay, so we can discuss about the closed loop control of DC drive. So normally what are the most important points for to be discussed? So in case of closed loop operation, we have to find out some reference one. Okay, we need to calculate some reference value, actual value, and compare with the reference value. So VR means you are compared with some reference voltage. Okay, so you can see that only closed loop can work. Okay, here you can see it's a differential controller. Okay, so plus minus is there. Plus means it is your reference value, means set point. Okay, in closed loop you give some of the set value. Okay, but output means it is your actual value that will compare with your set value. But in case of comparison, so that if those two value are not similar unit, so how it will be work? So it will not work properly. So in that case you have to add some of the sensing unit. Okay, sensing unit means you will add some transducer, you can say like that tacho generator. Okay, tacho generator you can use it. Okay, by using the tacho generator you can convert that speed to the voltage. Okay, means it omega is there, so you can convert that speed to the voltage, and you can compare that reference voltage with the actual voltage. That speed is coming after tacho generator, it's a transducer, so it will convert the speed to the relative voltage, means equivalent voltage. Okay, so if that amount of voltage is sufficient enough to compare with your reference value, sometimes what happens that voltage value is less, so you need to amplify that voltage, means scaling up that voltage. Otherwise another concept you can do, so you can sensing, you can convert them in such a manner you will get the actual value, and you can put the equivalent value of reference voltage. Okay, means it should be the actual nearer to the actual value of the speed sensing or the sensor output of the sensor. Then you can compare them, and you will get some error signal. That error signal will be passing through the speed controller. Okay, so speed controller is there. Normally we are using the PI controller as the speed. So why we are using the PI controller? What is the motivations for selecting the control of that switches? So normally basic motivation is that in PI controller you can minimize the steady state error, means that error is there, means you are comparing that value with your reference. So that actual voltage, actual speed is compared with your reference speed, na? So reference speed in terms of voltage. Okay, the unit of the reference speed in terms of voltage. So you are comparing them, so you will get the error value. So that error value should be minimal. So in case of PI controller, we are using the integral circuit. Okay, so integral, what is the concept of the integral? It can minimize the error. Okay, so integrating that portion and try to overcome the steady state error. Okay, that's why we are using integral. But the main problem is that integral response is quite slow. Okay, so but you know that motor inertia is also, you know, that mechanical time constant is very more than your electrical time constant. So there you can use the PI controller. So that is sufficient enough in respect of your motor inertia, in respect of your motor time constant, na? So time constant is more important. So you know, na, Zn method, Zn equals method. So how do we find out that value of that controller? Okay, in the by using Zn method. Normally we are giving the response in the open loop system. Means open loop system means you are feeding the response. You have the system. The what do you mean by the system identification? So one subject was there, one topic was there in control system, advanced control. I think you are able to recognize. Okay, so you are right now you are doing, I think, that subjects. Okay, so physical, I mean system identification. How would you identify the system? So you will give some, like your hysteresis. You can take some practical example. In hysteresis, what you are doing? So your VH loop is there. So you are increasing the value of H, and you are trying to say that how much variation of B is there. Okay, initially it is started from 0, then gradually it is increasing, means in linear way, y equal to mx concept. Okay, it is linearly increased. After then what happened? After certain value of H, that B is constant. Okay, you try to realize the curve. Okay, that was in your first year. Okay, not like in the first year, in machines all the time we are talking about hysteresis. Okay, so it's very popular topic in magnetics study. So that means it is saturated. Okay, so that study is your open loop. So you are changing your input and you need to see where your output is saturated, means where your output reach the non-linearity. Okay, saturation is an example of a non-linearity. Okay, so then what happens? You need to find out one slope for the linear zone, and you need to calculate the slope, how much value is there. So that will be the your time constant. After that you can go for the control design. Similar kinds of thing is there. So in machine, so you will change the input voltage. Okay, so and you need to check the speed of the machines for armature voltage control. Okay, so gradually you are increasing the motor speed from so you have to give some minimal value of voltage, then up to very low voltage, means it's again high current will be flow through the machine, that can burn out, that may cause for brownout of your machine conductor. Okay, that is not also been acceptable. So you have to put the rated value, means threshold value will be there. So from how much to how much, some band is there. So that amount to you can vary. Okay, so you have to put that value of that omega. So how much maximum speed can be achieved? Okay, then you have to plot one slope. Okay, at the base of your linear system, means linear zone. That will be your time constant. Okay, so of your PI controller. Okay, the speed controller. Then you can vary. Okay, then you can vary it. Then you can design based on that slope, that you can design your specific controller. Okay, and what is the parameters, means pole zero locations, pole zero and gain location of the controller. Okay, what do you mean by the controller? Controller having set of roots. Okay, so pole zero and the gain. Okay, that is well enough to discuss about the control. Okay, then you can control the speed. Okay, so that is called the system identifications or parameter identifications. Okay, the physical system parameter identifications. After that your converter is there. Okay, so what is the purpose of the converter? Then after speed controller, so you will get the control voltage, so that VC. Okay, control signal. Okay, control signal is there. That control signal will be compared with your repeating sequence, means voltage mode control. This is your voltage mode control. Okay, means outer loop control. So it will be compared with some repeating sequence. It may be square wave, it may be triangular wave. Okay, like your power electronic circuit. Okay, then we will get some of the PWM. If the control signal is compared with some triangular one, so you will get some PWM. That PWM will feed to your switches of the power circuit. Power circuit means in case of you can use buck converter circuit, you can use boost converter circuit, you can use buck boost converter circuit, whatever circuit is required, whatever power electronic circuit is required, when power circuit is required, you can use there. Okay, so that you can use and you can control the switch that output is coming, that PWM is coming from the circuit. Okay, after comparing with your control circuit with the repeating sequence, the PWM will be there. That PWM directly feed to the switches of your power circuit. If the switches are controlled, if the switches pulse means PWM will be varying. Okay, it will come later. Okay, so then you feed the switch, then switch will be turned on. Okay, with the according to the pulse sequence of your control signal. Okay, so if the control signal is varying, you have the triangular one. Now control signal is varying, so pulse width also been changing. Okay, you try to realize the problem. Okay, so you can understand. So pulse width also been varying. So by the variations of the pulse width, what happened? Your switch on off time also been varying. If the switch on off time is varying, so output voltage. Okay, output voltage, you know that armature voltage. Okay, that armature voltage means output voltage of the switching converter also been changing as per the changing of the VA value. So DC motor output means load torque also been changing. Okay, so input is DC, input is electrical, output is your load torque is fixed, output also been the mechanical, so motor torque also been changes as per the motor torque, that TL is your load torque. So after the comparison, okay, you will get some equivalent, you will get some of the output speed. That speed will be defined. Load torque will be decided how much load you have given to the motor. Load torque is more means motor will driving more current. Okay, motor will drive more current, drawing more current. Load is less means motor draw less current. Okay, so how much maximum current also been taken by the motor, that also been decided by your system definitions. Okay, so by the circuitry, okay, and the excitations of the system. So motor having some extra excitation, that excitation is coming from VA. Okay, that current also be coming from your converter. So converter current rating also been important, how much wattage. Okay, if your motor is 500 watt or 1 kilowatt and you are designing one converter for 10 watt, so definitely there is a mismatching of the power, it will not work. Okay, so at least as per the requirement of your motor power, so your converter power also been changed. Okay, if motor power is 10 kilowatt, your converter should be more than 10 kilowatt. Okay, so that is a physical system. So I am giving all those examples in the physical manner. Then omega will be there. If you changing of the load torque, okay, that means load torque means it is additional disturbance. You can realize the problem. So load torque is changing means load is varying. Okay, so load is varying. So definitely varying of load means changing of the current of the system. Okay, how the current is changing. If you want to make the speed is fixed. So if load is increased, so load current also been increased. So how do you increase that value of load current? So your converter on time should be increased. If converter on time is increased, means switch of the converter with, okay, switching pulse means converter on time. Sorry, the switch of the converter should be on for the more time compared to the previous conditions. Okay, for the more load. Okay, so your converter should be on more time. So how do you make it more time? So your pulse width that is coming from your speed controller. Okay, so that pulse width will be more. Okay, so on time should be more of the converter. Okay, so that's a way to find out the logic, set the logic of the system. Okay, so I hope all of you are able to understand. So by this way, you can control the system in closed loop feedback for the industrial drive operations. Okay, means industrial traction drives operations. Okay, the entire thing will be designed in the power electronics platform, power electronics and microcontroller based platform in your traction drives. Okay, so what are the most important points for your closed loop control of DC drives? I hope all of you are able to understand. If you have any doubt, you can note it down. You can put your doubt in the chat box. You can note it down and you can write it in the chat box, so I can discuss it after completing my session. Okay, so the speed of the DC motor changes with the load torque. Okay, so definitely load torque has changed, speed also changed. But in closed loop, end of the day, your speed should be in the range. Okay, it should not be very less than its. It should not be very as abruptly. Okay, so that variation will be given in the data sheet at the time of testing the manufacturer. Okay, so motor also being manufactured by some of the reputed company. So when the manufacturer tested the motor in their own lab, okay, or calibrate the system in their own lab, so they are preparing some data. Okay, they are preparing some data sheet. That data sheet is important for your system. Okay, so you have to maintain everything as per the data sheet given by the manufacturer of your motor and the control of the motor. Okay, what is written to maintain a constant speed. Okay, the armature and or the field voltage should be varying continuously by varying the delay angle of AC-DC converter or the duty cycle of the DC-DC converter. That I am telling you. So duty cycle of the DC-DC converter, it will be maintained, or sometimes if that DC-DC converter is not there, direct power supply is there, okay, only AC is available, you are just converting that AC to DC and fed to the motor. So what happens for this converter? So in that case, delay angle means firing angle. Okay, so delay angle is not the actual term, it is firing angle. So firing angle, that should have to be varied. Okay, in the practical drive system, it is required to operate the drive at a constant torque. Okay, at a constant torque or the constant power. So constant torque and constant power. When there are two ranges, so first range is known as constant torque, then the next range is constant power. In addition, the control acceleration and the decelerations are required. Okay, the most industrial drives operates as closed loop feedback system. So it is a closed loop feedback system. Okay, a closed loop system has some advantages to improve the accuracy. Okay, accuracy means you have to try to mitigate the, or you have to try to reduce the V, means steady state error. Okay, try to reduce that error. And fast dynamics. Fast dynamics means how fast your motor is responding with the variation of your load torque. If suddenly load has increased, like your lift, okay, so normally 4%, the rating of the lift is normally, it is written that 8% may carry. Okay, but normally where one family is always traveling to the lift, so more or less 5 or 4% all the time bearing. So it is your average loading. But if suddenly 8% are there, so definitely the loading also be more. So motor have need to more energy to pull it up, that additional another 4%. So that's why the rating of the converter, rating of the motor will be enhanced. Okay. Also the fast dynamics. If the motor or if the system is not performing very fast in nature, then it will be difficult. Okay. So that's why fast dynamics also important. And reduced effort and reduced effects to the load disturbance and the system nonlinearity. Okay, so you have to reduce the effects of the nonlinearity with the presence of the load disturbance. Means the system should not go to the saturation level. Means flux of the motor, okay, should not be to the up to the saturation level. You have to control the flux within the saturation level, means linear zone of operation, that I am telling you now. So for the system identification, you have to find out the slope, okay, where the most of the points are present in of the linear mode of the linear zone. Okay, so that is important. You have to find out the slope, and basically based on the slope you have to design your speed controller. Okay, and you have to try if that speed controller design, and you have to keep in your mind, so your flux of the system should be varying in this linear zone. It should not be go to the non-linear zone. If it is going to the non-linear zone, then problem is that it will be uncontrolled. So you will give you some input, but output will not perfectly working. Okay, that's the problem of the saturation. That should keep in your mind. Okay, for designing the speed controller of your drives. Okay, so another important features or points are there. So the block diagram that is given, the block diagram, this is your block diagram, it is given here. Okay, so the block diagram of closed loop converter fed separately excited DC drives is shown in the figure. That is your figure. So what is VE? That I am telling you the error. What type of error? It is speed error in terms of voltage. Okay, speed error, but in terms of voltage. If the speed of the motor decrease due to the applications of the additional load torque, okay, so additional load torque means the TL is your additional load torque. Okay, the speed control response with an increase the control signal VC So VC is your control signal, change the delay angle or the duty cycle of the converter. So VC, if you error has changed, if that error has changed, so the value of VC also been changed. Basically VC you can say like that is DC value. So you are comparing the DC value with some triangular value. Okay, so this is your DC value, means constant value. Okay, so if the DC value has changed like that in lower and upper, then what happen? It is comparing with that triangle. So the pulse width, that means that pulse width also been changed. Okay, that pulse width also been changed with the value of changing of DC VC value. So it is your VC and it is a repeated sequence. The changing of the VC, so pulse width also been changed. That is written the increase of the armature voltage of the motor. Okay, and increase armature voltage develop the more torque to restore the motor speed to the original value. So you have to restore that value of the speed. Okay, drive normally pass through a transient period until the developed torque is equal to the load torque. Okay, so that developed torque should be the equal to the load torque. Okay, so through a transient period. Okay, so the transient period it should be developed through the load torque. Okay, so as per the changing of the load torque, that PW should be varied. Okay, and your converter should work at the all the throughout the path, and it should be maintained good condition. Okay, so then we have to go for AC motor drive. So what are the most important features of the AC motor drive? So why we are switching the DC drives to AC drives? That in my last class I was discussed that the maintenance cost of that DC motor is comparatively more than your DC AC motor drive. So and we can switch it to the DC motor to the AC motor, and the cost. Okay, the cost of the motor also very less in AC motor, means you can compare the operations of the you can compare the overall cost of the DC motor, DC series motor with the induction motor, and the controlling. Definitely the controlling is more sometimes it's costly. Controlling is costlier than the DC motor. Basically in AC motor you have to use some either vector control or the scalar control. Normally we are going for the vector control, so we have to conversion is there. Basically in static you have to convert the AC 3-phase AC motor, and the controlling will be in the DQ0 model. DQ0 model means you have to change that you have to change the reference frame. Okay, from ABC means 3-phase to it will be converted to the 2-phase. Basically why we are going to convert from 3-phase to 2-phase, for getting the better control idea. Okay, so I am telling you na controlling condition in DC motor is easy compared to AC. That's why you are converting the 3-phase by using path transformation, Clark transformation. A lot of transformations are there by name. Okay, so you have to convert that ABC to DQ0. Okay, if you are converting from ABC to DQ0, then the controlling in D axis and Q axis quite easier. Okay, that's why you did that comparison, and you can use the same thing for again the power converter will be there. Okay, power electronics converter. So that duty will be developed by your controlling signal. Okay, from the duty you can also compare all the duty. You can also control the switches of your power electronics circuits. Okay, or power electronics converter as per the changing the switching logics, as per the changing of the pulse width of the switching logic. So definitely you will get the different outputs, means variable outputs as per your requirement, means as per the closed loop requirements. Okay, end of the day, for the very beginning you should fetch the input, analog input. What are the analog inputs are there? Normally we are fetching the motor speed. Okay, in outer loop. Okay, in inner loop other kinds of parameters you can also collect. Okay, but normally we are taking the motor speed. We have to maintain the fixed motor speed. So motor speed all the time should be calculated through the barometer, to the tachometers or other kinds of arrangement, other kinds of sensor, and you will get some electronic. Okay, you will get some electrical response or electrical signal. Okay, after converting after using the transducer. Okay, so physical system to electrical system, then you can get the error, calculate the error, and you can process the error. So the microcontroller board, and you will get it for the conversion AC/DC, sorry, three phase to two phase conversion, and you can control by installing the different controller. Okay, and you can convert, or you can control the switches of the switching converter, and that switching converter can feed to the motor. So what type of motor you are using? Normally you are using induction motor. Okay, so that's the basic concept. So as your input is DC, okay, so you are converting that AC to DC, means from pantograph you are collecting the AC, then what happens, through the transformer you will get the AC. Okay, and transformer having three winding, one is for traction, another two winding for the auxiliary operations of your locomotive. So from the traction, that winding is there, so from that winding you can convert that AC to the DC for comparison. So that is repel DC, again you can use the three phase or two phase, whatever may be your input, so you can convert to the DC. That DC is fed. Okay, that DC is used like a passing through the smoothing reactor. The smoothing reactor is there, so you will get the constant DC. Okay, instead of pulse width DC, that constant DC is fed to the inverter circuit. Okay, inverter circuit means again DC to AC conversions. Okay, it may be DC to three phase inverter. Okay, so DC you are giving, so you will get that three phase output. As per the output, you will directly connect the inverter to the load. Okay, what type of load? Induction motor load. Okay, so from the induction motor load, output of the motor, input is coming from the three phase inverter, means DC to AC conversion. Three phase AC is output of the inverter, and that AC, three phase AC is put to the motor, induction motor. And what is the output of the induction motor? It is your mechanical energy, means mechanical means you are getting the speed of the induction motor. Okay, so speed control is there, so you can get the tacho generator. You have the tacho generator, you can send the speed. Okay, from the tacho generator you will get the speed and process them. Okay, and you can process them, that speed. Okay, so how to process them? So you can tacho generator will get the electrical energy. Okay, electrical signal, that electrical signal again compare with the reference speed, equivalent reference speed. Okay, in terms of voltage. Okay, then you will get some error signal. That error signal also be there, it will be processed through the compensator. Then you will get the control signal. That control signal will be compared as per your logic. If it is an inverter, so what is the types of modulations are there? So there is a carrier frequency and the modulating frequency as per the logic. So from that control signal you can generate the pulse width, or you can generate the pulse sequence of the inverter. Okay, that pulse sequence is fed to the inverter switches. Okay, as per the changing of your motor load. Okay, as per the changing of your motor load, motor actual speed also will vary. Okay, so you have to keep that motor actual speed in fix. So you can sense the actual speed and you can process that actual speed through the processor unit, means controller unit. Okay, controller is situated in the unit of processor. So the processor is there, so processing that value, and you can mitigate that error. Okay, and you can find out the suitable PWM. You can generate the suitable PWM for making the motor speed constant, and that PWM directly feed to the 6 switches of that inverter, and that output voltage also will varied according to a pulse sequence. And you can control the inverter input, you can control the motor input, induction motor input, and make it the fixed. The output means mechanical energy, means you are making the fixed of the machine speed, and that speed can directly shaft, okay, directly connect with the pinion gear of the wheel of the mainline traction unit. Okay, so you can control the speed of the motor and you can control the speed of the locomotive. That's the basic introductions of the AC motor drives and their working principle. Okay, so how it will work. So the AC motor exhibit the highly coupled, okay, non-linear multivariable structures as opposed to much simply a decoupled structure separately excited DC motor. So you have to decouple it, means DQ complications are there for the controlling. Okay, but it is required for the induction motor. The control of an AC drive, generally require the complex control algorithm that can be performed by microprocessor or microcontroller that I am telling you, okay, or microcomputer, along with the fast switching power converters. Okay, the AC motors have the number of advantages. They are lightweight, up to 20 to 40% lighter than the equivalent DC motor. Okay, that's the basic motivation picking the AC motor instead of DC motor. Okay, are inexpensive and have low maintenance compared to the DC motor. So maintenance cost also very less in AC motor compared to the DC motor drives. They require the control of frequency, voltage, current of for variable speed applications. Okay, the power converters, inverter, AC voltage controller can be control the frequency, voltage, or the current to meet the drive requirements. That's the specific importance, okay, for using the AC motor drives instead of DC motor drives. All other points are there. So what are the important points? This power controller, okay, or the power converters, I'm telling you, which are relatively complex and more expensive, require advanced feedback control techniques such as the model reference, adaptive control, sliding mode control, field oriented control. All those cases you can see that the control strategy is depends upon your environmental behavior. Means adaptive control means suddenly that heating of the motor is increased. So how your controller can control the additional heat dissipation of the motor. Okay, so you have to reduce the on time of the motor. Okay, so then the fans are there. So fan all the time it will that blower. Okay, so that all the time it will give the air to the system or to the motor winding, so it can be cooled down. So you have to reduce the on time of the motor. So according to the adaptations of your scenario, temperature is there, maybe sliding mode, you can say like that, it is variable structure based control or variable structure based model. Okay, so again sliding mode having some advantages. Why we are using the sliding mode? Every control architecture having some of the motivations for picking such control architecture. Why we are picking those? Arbitrarily we cannot take it. Okay, so we need to know about the motivations. Okay, so that is most important concept. And field oriented control, and how much value portions we can vary the motor control, then voltage control, then field control, that is important. Okay, however, the advantages of AC drives overweigh the disadvantage. Okay, so advantage of AC drives also you can say like that, you can omit the disadvantage. So there are two types of AC drives: induction motor drives and synchronous motor drives. Okay, two types of drives are there. Okay, so AC drives are replacing the DC drives and are used many industrial and the domestic applications. Okay, so that's the issue. So we can use any of the applications, especially for the tractive effort, traction. Okay, that is our main concern. Okay, why we are using that one? So that traction is important. So that's why we are using it. Okay, so here you can see that induction motor drives. For operations of the induction motor drives, normally what type of operations we are doing? So in power electronics person, they are directly giving more thrust on VVF control and VYF control. VVF control means variable voltage and variable frequency control. That also be done. Okay, that also been done, but it having some limitations. Okay, it can be done after the base speed. Okay, but below the base speed and means up to the base speed, what type of control you need to be done? So that is your VYF control, variable voltage and variable frequency. Sorry, VYF control means you are making variable voltage and variable frequency, but making the flux constant. Okay, beyond that, when the flux is not constant, then you are not able to implement that method. Okay, so you have to use that method up to flux is constant. Okay, so you can see the characteristics. Okay, you can see the characteristics, torque slip or torque speed characteristics of the induction motor. Okay, so it is your torque, it is a forward motoring. You can see like that it started from zero. Okay, zero. So you can start it from zero, then you know the synchronous speed. Okay, so synchronous speed is there. So finally, and you will get the maximum torque. Okay, then up to that value you will get the zero. So zero means again the sleep, I think so. Okay, so sleep is 0 to like that. Okay, so you can vary it. So if you change that value, so forward motoring, then reverse plugging. Plugging means again it is in 4 quadrant. Okay, so that portion is shifted to here. Okay, so the configuration is there as per, you know that in drives, that portion you have already covered in drives. So the relation between s minus 2, that multiplication was there. Okay, so that relation you can recall. Okay, you can recall it and you can understand, I think so. Then forward regenerations. What are the methods for the speed torque induction motor can be controlled by stator voltage control? Common methods. Okay, so you can use the track, a three-phase track. Then rotor voltage control. Rotor voltage control only can be possible by changing of the rotor resistance, but it is not possible for the slip ring induction motor. Sorry, it is only possible for slip ring induction motor, not for the squirrel cage induction motor. Then frequency control also be possible. You can use the inverter drives or the cycloconverter drives. So both of the cases you can vary the amplitude as well as frequency. But inverter drives, if your input available input is DC, only you can use that inverter drive. If your available input is AC, so you have to use for switch to the cycloconverter. Okay, the control of the inverter and the control of the cycloconverter, both also been possible as a output frequency and voltage. Okay, then stator voltage and the frequency control, that two methods you can use. Stator current control. Okay, so all of the standard method you can already gone through, you have already gone through in your drives chapter. Okay, so I am not going to repeat all those things. So you have already gone through any of the standard book. You can follow Krishnan, you can follow the book of Dubey, you can follow the book of Professor P.K. Sen and they. Okay, so all three books are very renowned in the drives, for the basic drives. Okay, for the UG course students. Okay, so you can follow them, so you can get some of the idea from their side. Okay, to meet the torque speed duty cycle of a drive, the voltage, current and frequency control are normally used. Okay, so that's why we are using voltage, current and the frequency control. Okay, so induction motor drives, what are the most important points are there? For that we have to be discussed. The stator voltage can be varied by three phase. Okay, the stator voltage can be varied by three phase. AC voltage control, voltage fed, variable DC link inverter, pass with modulation means PWM control. That are the most common features. Okay, so that are the most common features, more implemented in idea. So when you are preparing your class notes, okay, so when you are preparing your class note, that I am giving all those things is going to be recorded, so you have the reference with you and prepare your class note and elaborate all those points. Okay, you can follow any of the standard drives books, any of the books. Okay, that whatever available in your internet resource, you can follow them and prepare the very good material, class note material, and you have to submit it time to time. Okay, that I am telling you the points, but and discussing about the motivations of the using those points and the details discussions about how the practical system is working. So you have to write the fair copy of note in your home. Okay, and you have to submit it with the regular interval. Okay, so however, due to limited speed range, okay, requirement, the AC voltage controller are normally used to provide the voltage control. Okay, the AC voltage controller very simple, that I am telling you. AC voltage controller means input side AC is there like auto transformer. You can vary the firing pulse. Okay, it's a 2 SCR is connected in anti-parallel. So in the single phase, for three phase 6 SCR will be there. For individual phases, two back to back, or sorry, two anti-parallel SCR should be controlled. Okay, should be silicon control rectifier should be connected. Individual phases, phase line. Okay, so you can control them. You can control the firing pulse of the SCR. The harmonic contents are high and the input power factor of the controller will be low, definitely. So sometime off, then it will be that firing pulse is standard, then we will get some control output. Okay, definitely harmonic will be high. So fundamental components, so it is different from the fundamental components means sinusoidal components. So definitely the harmonic automatically it will be high. So again you have to improve that input harmonic. So input harmonic means depends upon your ripple and the distortion factor. How much distortion is there, that you need to calculate, and you have to increase the input harmonics. Okay, sorry, input power factor. They are used mainly in the low power applications such as fans, blowers, centrifugal pumps, where the starting torque is low. Okay, starting torque is low. They are also used for the starting high power induction motor to limit the inrush current. So in case of induction motor, you know that induction current is 2 to 5%, I think so. Okay, so that is another issue. In case of induction current, so a lot of even harmonics also been entered to the system. So how do mitigate that, yeah, harmonics error? So that is another study. Okay, so that you can follow. Okay, so here you know that we are using the slip ring induction motor, that you can change the rotor resistance. You know the characteristics, speed torque characteristics, torque slip characteristics. Both of the characteristics is given. So increasing of the RX, so that value is different. Okay, peak is same, but it is changing. Okay, changing of the load carrying capability. Okay, so that is given, that varying of the resistance RX. Okay, developed value. If RX is referred to the stator winding and to the RR equations may be applied to the determine the developed torque. Okay, the typical torque speed characteristics for variation in the rotor resistance shown in the figure. So that figure it is given. Okay, three phase supply is there, stator is there. So rotor, you are changing the resistance, rotor resistance you are going to change it, so that can have an effect, good effect. Okay, it is for the slip ring induction motor. Okay, or wound rotor induction motor. Okay, method will increase the starting torque. So what is the motivation? So it can increase the starting torque while limiting the starting current. So that is more important motivations. Okay. So then what you need to see, then insufficient, inefficient method, and there will be the imbalances in the voltage and current. Okay, that you can observe, that imbalances of the voltage and current. If the resistance in the rotor circuit is not equal, that kinds of problem you can observe. The slip ring induction motor is designed to have a low rotor resistance. Okay, low rotor resistance, so the running efficiency is high and the full load slip is low. That are the important features. Okay, so slip, you can go for the maximum torque by varying, means you are increasing the slip, you can go for the maximum torque. Okay, some examples are there where the starting and braking for wound rotor or slip ring motor, so both are there. So it is a plain highest, you can implement a rolling mill. Okay, or the cotton mill, different mill applications, mean rolling, where the rolling machines you are using, that type of application you can observe. Availability of the rotor winding to for changing the rotor resistance. Okay, so you can change it, so rotor offer the greater flexibility and the control. Okay, however it increase the cost need to maintain due to the slip ring and the brushes. The wound rotor motor is less widely used to compare with the squirrel cage motor. Okay, so why it is less widely used? Basically specific applications are there only for the wound rotor are used instead of squirrel cage, but in tractions we are normally using squirrel cage. Okay, so it is power electronics control by, you know that very common features from the any of the drives books. So slip control of the DC converter, so slip power recovery. So you are getting the pulse DC bridge are there, it is uncontrolled. It may be also change in the control bridge. Okay, so smoothing reactor is there, ID, and you can control the GTO based controlling is there. So you can get that value, VDC value you are getting. Okay, so that range is how much range? R equal to R whole into 1 minus K. So what is LD is acts as a current source, and ID is the current source, LD is the inductor. LD is the inductor, ID is the current source, constant current source if behave like it. Okay, the DC converter varies with the effect of resistance. We found as the equation is given where K is the duty cycle of the DC converter, and motor speed can be controlled by varying the duty cycle, and it is air gap power, the portions of that air gap power which is not covered into the mechanical power is called the slip power. So you are getting it from the slip, so that's why slip power. So it is known as slip power recovery method. Okay, so slip means rotor resistance, you are wasting of the energy. Okay, so in normally previous case, if you see the rotor resistance varying means you are wasting of that energy, but here you are not going to waste it, you are again take it from the slip and you are going to feedback that energy to the main grid. Okay, that's why it is known as slip power recovery. Then frequency control also be there. Okay, so frequency control map that I have already discussed. By using inverter control or the cycloconverter control, you can control the frequency, means VYF control up to the base speed. After the base speed, variable voltage, variable frequency, means you can control the frequency for maintaining the power constant. Okay, so that too only possible for the power electronics converter. So if the availability of the source is DC, so you can use the inverter circuit. If the available source is AC, you can use the cycloconverter circuit. But initially it was also used by using the Arno converter circuit. Okay, that is single phase to three phase conversion by using motor. Some machines, Arno converter is the machines. Okay, so it can convert the three phase to single phase to three phase and the vice versa. Okay, so that is discussed about your AC drives and the DC drives for the traction motor. I think this is enough for today's class. So if you have any kind of discussions, if you have any kind of question, okay, if you have any kinds of doubt, you can ask me. So I can you can ask me, so I can discuss it again, or you put your question to the chat box. So sometimes we can also able to discuss it. Okay, so I think this is enough for today's session. So I think there is no question to the chat box. I think we can complete it. So just wait for a moment if there is any questions from your side. Okay, so I think there is no question. So okay, so we can complete today's session here. Okay, thank you my student.